we're going to take a little look at the beginning of complex numbers. So the first thing we're going to do is just link this back to our junior cert. So in the junior cert, we would have looked at different types of numbers. We have them written there: natural numbers, integers, rational numbers, irrational numbers, and real numbers. They were all at junior cert level. So basically at junior cert level, everything is a real number. And then we divide them up into different categories: rational numbers and irrational numbers. So a number is either rational or irrational. If it can be written as a fraction, it's rational. So for instance, 3/4, or the number 10 can be written as 10/1. And irrational numbers then are very specific. They're numbers that cannot be written as a fraction. There are very few of these. The roots, square root numbers, unless they're perfect squares, or pi, numbers that go on for the decimal goes on and on. Integers and natural numbers then, so something can be an integer. If it's a positive or negative, it must be a whole number. And then natural numbers are our positive and whole numbers. So that's all the real numbers, but in Leaving Cert we do complex numbers, also known as imaginary numbers. So a complex number then is when you put a real with an imaginary. So if we look at the very top there, it says a complex number is any number that is in the form of a plus bi, where a and b are real numbers. So for example, what we might have there is we might have 2 plus 3 and then I. There's always going to be an I part of it to make it a complex number. The I part is what the imaginary part of the number is. Complex numbers come from the square root of negative numbers. So the first thing we're going to do is we're going to take a little look at the example one there. We're going to attempt to solve that. So have a little think about how to solve it, and then if you can do that, go on ahead yourself and do it. If you're not sure, to solve something like this, we're going to use the minus b formula. So to use the minus b formula, we're going to pick out our a, our b, and our c, and our minus b formula then is going to be minus b, so that's minus the 2, the plus 2 there in the middle, and then plus minus the square root of b squared, which is 2 squared, minus 4 times a, the number in front of x squared is the a, and that's 1, and then c is going to be the number 2, the last one. So if I want to just label them, that's the number a is 1, the number b is 2, and the number c is 2. That all goes over, so our minus b formula goes over 2 times a, and that's 2 times 1. Now if we put that in the calculator, what's going to happen is we're going to get an error. And the reason why we're going to get an error is if you look underneath the square root, we're going to end up with 2 squared is 4. Take away 4 by 1 by 2, which is 8, which is going to give us a negative 4. And that's where the complex numbers comes in, is if we have the square root with a negative number underneath. So if I tidy this up a little bit and just do it out manually, I'll have minus 2 plus and minus the square root of negative 8 all over 2. The negative 8 underneath the square root is the complex number. Sorry, not negative 8, negative 4. So negative 4. So it's the negative there underneath the root that makes it a complex number, or makes it an imaginary number. So what we need to do is we need to deal with the negative 4, the minus 4 underneath the square root. So to deal with the minus 4, what we do is we get the square root of the number, and we get the square root of the minus. The square root of the number is just the normal square root, that's just a 2. The square root of minus 1, that's where I comes from. So anytime we have the square root of minus 1, we change it to be an I. So my next step here would be minus 2 plus and minus the square root, or sorry, not square root because we've gotten rid of that now. It's going to give me 2 and I. So again, the 2 comes from getting the square root of the 4. The I comes from the fact that if we have the square root of a negative 1, that gives us the I. And that goes all over the number 2. So now, because everything there divides by the number 2, we will divide everything by the 2. We don't cancel a 2 and a 2. We divide each part by 2. So if I divide each part by 2, I have a minus 1, and I have a plus and a minus 2i. So that's 2 complex numbers. It's minus 1 and 2i, and it's also minus 1 minus 2i. They're 2 complex numbers, and they are 2 complex roots for that quadratic that was in our question. If we take a little look at the writing underneath, it says it is taken that the square root of minus 1 is equal to I. And from there we can write all the numbers in terms of I. So therefore we have the square root of the minus 4, that's where we're getting the 2i. We're going to practice a little bit of that now in a second. In your exam, when you get the exam questions, on top of the paper will be that the square root of minus 1 gives me I, or the other way they can write that is they can say I squared gives minus 1. And that just comes from, if I have the I is equal to the square root of minus 1, it's just by squaring each side, we end up getting I squared equals minus 1. So either of those is acceptable. So you can use those to change the minus 1s into I's. Now, if we take a little look at just doing that process, so we've seen now why this is being used, because we can't do anything else if we end up in this situation here. We're now going to take a look at actually applying that idea. So underneath here, we're going to take a little look at trying part 1 there. So again, if you know what to do, try it yourself. I'm going to go through it now. So the square root of minus 25, again, because that will change to the square root of minus 25, that's the same as doing the square root of 25 multiply the square root of minus 1. I'll end up with the square root of 25 is 5. The square root of minus 1 is always I. Same thing for the square root of minus 9. I know that's the square root of 9 and the square root of minus 1. And that gives me 3. And then the square root of minus 1 gives me I. And again, you can do the little extra part if you want. But if you know you're just looking for the square root of the number, the square root of 225 is 15. The minus there means I'm going to end up attaching an I next to it. And last little one then, the square root of minus 144, that's going to end up giving the square root of 144, which is 12. The minus means I stick an I beside it and it becomes the imaginary number. Looking at these underneath then, sometimes we'll be given an I with a power and we have to then write that in terms of a power of 2 is the highest really. So you really don't see powers that are higher than 2. Any powers in an imaginary, you change them to be I squareds or I's or minus 1s. So we don't see any power just with the I that goes above the 2. So when they're asking us to simplify the following to find a repeating pattern, the first one is fine because it stays as I. The second one then, I squared, I can change that to be minus 1 because we know that from earlier from up here. So I squared always changes to be minus 1. I cubed then. I cubed changes to be. So if I think about I cubed and I want to know, I know that the I squared is worth minus 1. I can say I cubed is the same thing as saying, I squared multiplied by I. Because that gives me I cubed. I squared is minus 1 multiplied by I is just minus 1I or minus I, whatever way you want to write it. I to the power of 4 then, if I want to split that up into I squareds, because I know what I squareds are worth, I have an I squared multiplied by I squared. And that is just minus 1 multiplied by minus 1, and that gives me a positive 1. So if I look at the pattern that I have now, I can see that I have I is the first one, minus 1, minus 1I, and 1. And we keep going doing the same thing. So I to the power of 5. How do I split that up into I squareds, I's? So that's going to be an I squared multiplied by I squared multiplied by I. That gives me I to the power of 5. And again, that's going to be minus 1, and then just an I left at the end. Minus 1 by minus 1 is a plus 1, I. There's my next number. I to the power of 6 then. That's going to be I to the power of 2. Now that I can write multiply by I to the power of 2, multiply by I to the power of 2, same as I was doing earlier. But I also know that that just means that there are going to be 3 of these. So I can also write it like that if I want. I squared is just minus 1, and that then goes to the power of 3. Or it's just minus 1 times minus 1 times minus 1, which gives me minus 1. And there's our next part of the pattern. There's our 6th part. I to the power of 7 then is going to be I to the power of 6, which is I squared to the power of 3, and I have an extra I then after it. So really, it's going to just be minus 1 cubed multiplied by I, and that's going to give me a minus 1I. Now, if you look at the pattern that we have so far, we have I minus 1I, and 1. And then we have I minus 1 and minus 1I. So if you look, it's actually a 4-part repeating pattern. And we have I to the power of 8 then. If you notice that, you can just say, okay, well, I know the next one then is going to follow the first 4, and it's going to be a 1. I to the power of 9, again, will follow the first 4 patterns, and we get an I. And I to the power of 10, again, we're going to look at the pattern, we're going to get minus 1. And there's our 10 different numbers in our pattern, and it becomes a 4-part repeating pattern. So if we were asked to find the 50th pattern or the 30th pattern, we can now do that. Okay, so let's take a little look at the part 3 then. So for the part 3, we have I to the power of 4. So I to the power of 4, we've actually already done that. But if you were asked, rather than having to go and do out that pattern and go up to the 4th one and or go and find your pattern, you can again always just do it a little bit quicker by checking how many I squareds do I have. So it's going to be I squared, that's going to happen twice, which is really minus 1 squared. Minus 1 by minus 1 is just a plus 1. If I go back and I check my pattern, the fourth one is also a minus 1. I to the power of 10, and again, we have already done that one, so we know it's going to become the one that's over on the right there with the pink is minus 1. But then what we can also say is that's going to be I squared. How many I squareds am I going to have? I'm going to have 5 of them. Minus 1 to the power of 5. Well, as long as minus 1 multiplies by minus 1, it gets us a plus. So we'll end up with an extra minus 1 at the end. We'll have a minus 1. And the last one then, I to the power of 15. How many I squareds do we have there? Well, if I have 7 of these I squares, that brings me up to 14. I'm going to need another I to get to 15 of them. I squared then is going to be minus 1. There's 7 of those. And I still have the I then. Minus 1 to the power of 7 will mean that I'll have minus 1 and minus 1 will give me a plus 1. But I'll end up with 1 left over, minus 1 and I. And again, you can always check in your calculator what is minus 1 to the power of 7. Because that will give you that it's just a minus 1. Same with the 5, minus 1 to the power of 5, just if you can't figure in your head what it is. So that's the very basics. That tends not to come up, but it can be asked. The top part there, solving something like that and knowing how to do that, that will come up later again, but it's just to explain why we do this or where this comes from. So that part there, that part 1, with the writing numbers in terms of I, that can be a little bit tricky. So do practice a little bit of that. And what we're